The topic for today's video is flow through pipes in series or flow through compound pipes. Like when we're having a series of pipes, then how we can find the equivalent length of compound pipe. For that, we have an equation which we'll derive in today's video. Here, I have drawn a diagram like this. I'm having three pipes. When the flow takes place from the first pipe to the second pipe, then you will observe that there is a sudden contraction. From the second pipe to third pipe, there is sudden enlargement. Here, suppose the length of this pipe is L1, diameter is D1, and velocity of flow is V1. The frictional coefficient is represented as F1. For this second pipe, the length is L2, diameter is D2, and the velocity of the flow is V2. And the frictional coefficient is F2. Then for the third pipe, the length of the pipe is L3, diameter is D3, and frictional coefficient is F3. The velocity of the flow is V3. The major loss will be the frictional loss. Here let me just write this as A and B. These are my two tanks, or you can say two reservoirs. Here this, which is the difference between the water level between A and B, that is known as H, which is my total head loss. Now let's just write the equation for discharge. Discharge through all these three pipes will be same. That is Q is equal to, for the first one if we say, it is A1V1. Then for the second one, it will be A2V2. And for the third one, it will be A3V3, which is Q is equal to A1V1 equal to A2V2 equal to A3V3. Then we'll consider the minor energy losses. First one will be here, which is my entry loss. Then the second one will be due to sudden contraction, which is here. Then the third one will be due to sudden enlargement, which is here. And the last one will be the exit loss here. This is just for your understanding purpose. I have drawn these ovals. You don't need to represent it. We'll just write the equation for the head loss, which will be entry loss is given by the equation 0.5 V square by 2G. For the first pipe, it is V1, so we'll write it as 0.5 V1 square by 2G. Then for the first pipe, we'll have to consider the major energy loss, which will be 4 F1 L1 V1 square upon 2G D1 plus, now we'll consider the loss due to sudden contraction, and that is given by the equation 0.5 V square by 2G. Here for the second pipeline, it is V2, so we'll write 0.5 V2 square by 2G plus 4 F2 L2 V2 square upon 2G D2. Then we'll consider the energy loss due to sudden enlargement, and due to sudden enlargement, the head loss is given by V1 minus V2 whole square divided by 2G. Here it is between pipeline 2 and pipeline 3, so it will be V2 minus V3 whole square upon 2G plus the major energy loss, which is 4 FLV square by 2GD. For the third pipeline, it will be 4 F3L3 V3 square upon 2G D3. And finally, we'll consider this exit loss, which is given by v square by 2g. Here it will be v3 square by 2g. This way you can write the equation for the head loss. Now one thing we are doing is, here we are neglecting the minor energy losses. We are just considering the major energy losses, and from that we'll write the equation for the total head loss. So now my total head loss will become equal to 4 F1 L1 V1 square upon 2 G D1 plus 4 F2 L2 V2 square upon 2G D2 plus 4 F3 L3 V3 square upon 2G D3. We have the equation for discharge, which is Q is equal to A1 V1 equal to A2 V2 equal to A3 V3. Now from this, if I write making V as the head of the equation, then V1 is equal to Q upon A1 and area is equal to pi by 4 D square, which is pi by 4 D1 square. This 4 will go up, so it will become V1 is equal to 4Q upon pi D1 square. Same way for V2, it will be 4Q upon pi D2 square, and for V3 it will be 4Q upon pi D3 square. We are going to replace these values in our equation of the total head loss. That is, we'll replace here V1, V2 and V3. And also one more thing we have, which is the frictional coefficients will be the same for all of these three pipes. That is, F1 is equal to F2 is equal to F3 is equal to F. And the total head loss we represented by this equation, which is 4 FLV square upon 2GD. Now here I can write that my V is 4Q upon pi D square. Firstly, let me just write it. 4FLV square upon 2GD is equal to 4FL1 into, instead of V1, it will be 4Q upon pi D1 square. Whole square of that will come upon 2G D1 plus 4 F2 L2 here only I'm just placing all of these values. That is, I'm replacing my V2 with this 4Q upon pi D2 square, and the whole square of that will come because we are having V2 square divided by 2G D2 plus 4F3 L3 V3 square. Now here this V3 is 4Q upon pi D3 square, and whole square of this will come upon 2G D3. Also one thing you might have noted that I have already replaced F1, F2 and F3 as F. Now you can see here that this 4F2G, 4F2G, everywhere it is common, so we can just cancel it. One more thing we'll do is, as I already told, that here instead of this V, we can write it as Q upon pi by 4 D square, which is 4Q upon pi D square. That also will get cancelled. That is, we can cancel this 4Q upon pi because everywhere it is common. 4Q upon pi whole square will get cancelled because everywhere we are having the square. After cancelling that, we'll be left with In the denominator, we are having this d square whole square. That, let me just write it separately and show it to you. This d square whole square will be d raised to 4, and also we are having one more d, so it will be d raised to 4 into d, because this d raised to 4 will get multiplied in the denominator with this d, hence it will become d raised to 5. And then we can just write this, which is L upon d raised to 5 is equal to L1 upon d raised to 5 d1 raised to 5 plus L2 upon d2 raised to 5 plus L3 upon d3 raised to 5. This equation is used to find the equivalent length of a compound pipe, and this L is known as the equivalent length of a compound pipe, which is, we call it as a compound pipe, or we say that the pipes are in series. We can even represent this equation in another way, which is making L as the head of the equation. We can just write this equation as, here I'll just multiply this d raised to 5 with all of these terms, that is, I'll just multiply it on the right hand side. So it will become L is equal to L1 into d upon d1 whole raised to 5 plus L2 into d upon d2 whole raised to 5 plus L3 into d upon d3 whole raised to 5. This equation you will have to remember, and this is how you can derive the equation for the equivalent length of compound pipes. Thank you.